Number 17 on the 2025 AMC 12B or number 21 on the 10B. Problem. Each of the 9 squares of a 3x3 grid is colored red, yellow, or blue in such a way that each red square shares an edge with at least one blue square, each blue square shares an edge with at least one yellow square, and each yellow square shares an edge with at least one red square. Colorings that can be obtained from one another by rotations and or reflections are considered the same. How many different colorings are possible? So there are 9 squares on a 3x3 grid. Like that is the 3x3 grid. It's either red, R, blue, B, or yellow, Y. Now, each red square shares an edge with at least one blue square, and so on. So R, B, Y. That means that this is in a cyclic relationship. So therefore, we can set one color as 1, 2 colors 2, and 3 color as 3, and then if, for example, something like 1 1 2 3 3 3 3 1 1 works, like, by the way, it doesn't work, then we can put 1 as R, 2 as B, 3 as Y, and then do the same. 2 equals B, 2 is R, 3 is B, and 1 is Y. 3 is R, 1 is B, 2 is Y. That was also satisfied, so we can multiply by 3 since it's in this cyclic relationship. So therefore, let's draw the grid 3 by 3. So first case, let's say that R is in the middle. Okay, so let's call R 1. So therefore, it's going to be like this. So 1 is in the middle. Now 1 absolutely needs 2. And also it said that in the question, it said that rotations and reflections are considered the same. So let's just bolt it there. So now 2 is here, it does not move. Now 2 absolutely needs 3, so 3 can be here or here. However, because reflections aren't counted, you can just erase that and then consider that 3 is here. Now 3 absolutely needs 1 for edge, because it's kind of like that, so therefore 3 needs a 1 to be here. Now again, 1 needs 2 to be here, 2 needs 3. Now 3 needs 1, but 3 already has 1 on top. So therefore, we have 3 boxes that are empty. So here, 2, 1, 1, 3, 2, 3, empty, empty, empty. Now, just like we said that this box in the middle is 1, let's call this, let's put this as 1. Let's put 1 inside, and then we can put 2 and then 3. Because if you see, if we start from the center, then it's gonna get harder because, for example, if this is here, then we don't know how to pick. However, if we start from this underbox here, we can just go up, which is much more easier than that. So let's start from 1, 1, 3, 2, 1, 1, 2, 3. Now, what to put in this box? So firstly, 1 absolutely needs 2, so therefore we need 2 to be here. And then 2 absolutely needs 3, so we need 3 to be here. 3 needs 1, so that does not work at all. 2, 3, 2, 1, 1, 2, 3. These are all fulfilled. Let's call fulfilled means that they don't need any more because they already have what they need. 2 needs a 3, but 3 is already here, so this box can be anything. It can either be 3 or it can either be 1. It cannot be a 2 because 2 needs 3, but there's no 3 around. Oh, it can also be 2 because we can put a 3 at the top. Now for the first case, 2, 2. 2 absolutely needs a 3, but 3 needs a 1 does not work. 3 absolutely needs a 1, 1 needs a 2 works. Also, because 3 already has a 1 here, we don't actually need to do that so 2 can also go here. 2 needs a 3, so it works. 3 cannot go in because there's no 1. Now for 1 already has a 2, so this can either be a 2, 1, a 2, or a 3. 1 needs a 2, it works. 2 needs a 3, does not work. 3 needs a 1, it works. So therefore, we get 4 cases from here. Now on to the next case, 3, 2, 1, 1, 2, 3, and 3. 3 absolutely needs a 1. Now 1 needs a 2. That does not work because 2 needs a 3, there's no 3. So therefore, we got 4 cases. Now we gotta multiply by the cyclic R, B, and Y, which we put as 1. Now also, we don't need to change the center here, which we put as 1. Here I'm circling blue, because 1 can be anything. Because of the cyclic here, 1 can either be R, the centerpiece can either be R, B, or Y. So therefore, our answer is 12, so it's C.